Hey everybody, hope you're staying safe during this COVID time and that you can use these videos to help you understand a little bit more about trigonometry. Now I know I've posted a booklet to the teams, but these videos should help to teach you the lessons or the big ideas behind the lessons in the booklet, and I think it'll be great. Well, the first thing we have to know is that trigonometry is an understanding of right triangles. So if we remember Pythagorean theorem, and we should because it wasn't that long ago, we know that if we take a side A and square it, and a side B and square it, and if we add those two together, we'll get the third side squared. Now that's a unique property for a right angle triangle. Here's an example of it that we can do. So let's say, for example, we've got a right angle triangle that's 3 meters by 4 meters, and we want to find the hypotenuse. Well, we just use the formula, so we'll go 3 squared plus 4 squared equals the long side squared. That's supposed to be a square. Good. Now, 3 squared is 9. 4 squared is 16. C squared, well, we don't know what that is, so we'll just leave it like that. And 9 and 16 is 25. Is equal to C squared. Now, some kids would say, but that makes no sense. If this side is 3 and this side is 4, well, how could this side possibly be 25? I mean, we know it's going to be longer, but not that much longer. Well, you're right. Essentially, what we have to do is we have to square root to get rid of that square. And if we do it to one side, we have to square root the other side, because that's algebra and that's fair. And Mom said I have to treat people fair. So 5 is equal to C. And that's a Pythagorean triple, 3, 4, 5. So we can use the Pythagorean theorem for a lot of things, a lot of different situations. Like, for example, here's some real nasty rocks around a lighthouse. Here comes the boat. How far away is it? Pythagorean theorem, because it's a right angle triangle. And here's this fella, he's out doing self-isolation during these COVID times. He's flying a kite, and he's this far from where the kite is, and the kite is straight up, and he wants to know, how long is that string, or how high is the kite, or what's his distance? Pythagorean theorem, because of that right angle. Well, that's all cool. We don't have to actually do those examples because we've done a lot of Pythagorean theorem. What we want to do is head towards this thing called trigonometry. Okay, here's another point that's important about these right angle triangles. We know that if two right angle triangles are similar, their sides are proportional. Here's an example. So I've got a right angle there, a right angle there. I've got a 40-degree angle there and a 40-degree angle there. That means that this third one also has to be the same, because they're all made out of, each triangle is 180 degrees, and take away 90, take away 40, it's got to be the same for both. Anyway, in this situation, we can see that the two triangles are similar because they both have a right angle as well as a corresponding 40-degree angle. Now, we can't use the Pythagorean theorem because we don't know the height of the tree. I mean, we could figure out the length from the guy's head to where the 40 is, but that doesn't help us out with the other one unless we know something about similarity of polygons. Well, with similarity of polygons, all we have to do is set up a ratio. So on our first triangle here, this 5 and this 7, they go together because they're like a family, so 5 and 7. And they correspond or are similar to the x and the 14. And I've taught you guys a lot about this, but this is a great time to use Amazing Dr. Z. So always start at the x. Amazing Dr. Z is equal to the one across if you multiply the corners and divide by the last. So here we'll have x is equal to 5 times 14 divided by 7. Well, that's just a lot of math. 5 times 14 divided by 7. It's going to turn out to be 10. Now, most kids can see that 7 doubles to 14, to be proportional. 5 has to double to make 10. So we can find the height of the tree, and that's an easy example, but what really needs to be understood is why this works. This works because both triangles have corresponding angles that are congruent, which means the same. And at least one of the corresponding sides are proportional. So in its a way, it's a key that it works because the angles are the same and the sides are proportional, which means they grow in the same amount. Well, here's a fairly complex example, but these two triangles are similar, and we can use their properties of similar triangles to get a lot of information, like how far is the focal point, how big is the image, and all that sort of stuff. So if we understand if two shapes are similar, and in this we're talking about right angle triangles, and their angles are the same, and their sides proportional, we can do trigonometry. Okay, now let's just go to the next page here. Okay, now let's get back to Pythagoras and similar triangles. Each of these methods are great for finding a missing side or a missing angle, but what if you only knew one side and one angle of one triangle? Or what if you know two sides and needed to find the angle? Could you find the rest of the triangle's sides and angles? And the answer is, of course, yes. And you know it would be, because why would we ask that question if the answer was no? So at our level, we'll look at trigonometry involving only right angles. In grade 9, we worried about the Pythagorean theorem. In grade 10, we learned about the 3 basic trigonometric functions. In grade 11, we see that we can use combinations of trig ratios to solve more complex problems. And lastly, in grade 12, we learn about non-right angled trig. Well, here's an example of a grade 9 problem with a triangle. And that's basically A, B, C. A squared plus B squared equals C squared. So that's a grade 9 problem with a right angle triangle's Pythagorean theorem. Here, let's make that a good looking A there. Good. Okay, so here's an example of a grade 10 problem with trig. And you're in grade 10, so this is the kind of stuff we're going to do. And basically what we're going to do is we're going to want to be able to be concerned about one triangle at a time. It's going to have an angle, and it's going to have a side, or two sides and no angle. The idea is, in this unit, we become aware of angles in trig. Now, don't panic. We're good teachers. We can help you out with that. Okay, now let's have a look at what happens in grade 11. So in grade 11, we've got a problem with two triangles for trigonometry. Now, what we call these guys, we would call them a nested triangle. So I've got a right triangle there, and then I've got a right triangle here. So they both share that right angle. And then they've got different angles, and then it's, hint, hint, it's a big subtraction problem. But don't worry, by the time you get there, you'll be so good at trig that grade 11 stuff is just one more little trick. Okay? Now here's an example of a grade 12 problem with a non-right angle triangle. So for example, we got a cell phone, a couple of cell phone towers. Somebody might want to know what angle is that at. Somebody might want to know a distance. It's all good. And if you look here, you can see we got the a squared, b squared, c squared, d squared, c squared, a squared. You can see that there are hints of Pythagoras in the formulas for non-right angle triangles. It's okay. It's all cool. All right. Now, so trigonometry is the relationship between angles in a triangle and the length of its sides. In this unit, we'll focus on right angle triangles. Check this out. Let's say we want to build a right triangle that has a base of 5 meters. Now that's important because that's the only thing that's not going to change. So let's just highlight this sucker right there. That 5-meter base is going to stay the same. Now, we notice that as we put this hypotenuse on, and we're going to do it with a slightly different color here. As we draw on this hypotenuse, the angle gets a little bit bigger. Draw on a new hypotenuse, and the angle gets bigger and bigger. In fact, we could see it get larger and larger. In fact, we can even measure that. So let's do that. Okay? So let's bring over our protractor here. Make it a little bit bigger, put it right down there, and we just finished a unit on angles, so this should be all right. Okay, so if we look at the black line and we go up, let's just do a little highlight here. So as we go up here, we notice that the angle right there is about 22 degrees. Then as we go up a little higher to this red line, we notice the angle looks like it's about 32 degrees. And then as we go up even higher, we see that the angle is approaching about 40 degrees. Now, the base has stayed the same, so that's important. If the base stays the same, but that hypotenuse, if the base stays the same, but the hypotenuse gets longer, well, the angle changes. Whoops. Yeah, the angle right here changes. Right in there. Now, let's just have a word about that symbol there. Okay, now this symbol is called theta. It's a Greek word which has a big history. In their alphabet, it's like the third letter or something like that, but essentially it means death. And back in the day, if you were in front of a judge and you were convicted of a capital crime and were going to put to death, that's a symbol they put on your arrest warrant. But in terms of geometry, much happier, it stands for the angle that we're looking for. So it's called theta. And it's kind of like how we use x all the time in algebra. So let's do this right here. We're going to measure theta. So here we've got a base that's 5 meters. And here we've got another side that's 3 meters. And what we want to do is we want to just measure this. We're going to use it in a little while, but we just want to get an idea for how much that is. So a base at 5 and a height of 3 meters gives us an angle that's about, there we go, 35 degrees. And we'll put that there. Okay, 35 degrees. Now that's going to be important later on in the lesson because we're going to prove that over and over, and that's part of the whole beauty about mathematics, especially trigonometry, is you can prove this stuff. Okay, now there's two important ideas here. If we know the size of one side of a right triangle and an angle, the other two sides can easily be determined. Or if we know two sides of a right triangle, we can find the corresponding angle. That says angle. Oh, that's why I teach math. So once we know a side and an angle, it can only be built with the corresponding measurements. Otherwise, it wouldn't be a right triangle. And once we know two sides of a right triangle, we can determine the corresponding angle. Otherwise, it wouldn't be a right triangle. This is because the lengths of the sides of a right triangle correspond to a given angle. If two sides of a right triangle are 5 and 3, and the angle has to be 35 degrees, otherwise it wouldn't be a right angle triangle. So from what we did above, let's take this protractor here, Okay, we'll make this just a little bit bigger. And what we're going to see here, this is 5 and 3, like our example above, okay? And we're just going to remeasure it here to make sure we're, you know, the universe hasn't gone sideways on us. We're just going to see what's going on here. Good. We're going to bring this in a little bit. And we can see it's 35 degrees. Perfect, okay, 35. So 3 and 5 is 35 degrees, okay? Now, let's get this out of here for a second. Now, let's change this a little bit. Let's say that we've got 5 meters, but only 2.5 for height. Well, if that's true, we've changed something. We've changed one of the sides. So it can't be 35 degrees anymore. Well, let's just see if that's right. And voila. We see it's about 25 degrees right there. About 25 degrees. So I changed the height of that right triangle, which changed the angle. Okay? Well, some people would say, oh, all right, Mr. Chamber, you're a big old smarty pants. How about this? How about we keep the height the same and change the base? Remember, we're measuring from theta, and theta is right here. Okay? Well, okay, I'll say, let's just grab this pen, put this guy right on here, and voila. What do we got? Man, it's about 60 degrees. So we wanted, whoops. This was 35 degrees. We changed one thing, and it was a different number of degrees, 25 degrees. We changed a different thing. Or, I'm sorry, well, that's the same. We changed this thing, and it turned out to be, what was that, 60 degrees? So if we know that this is 35, and we know that this is 5, this has to be 3 meters. It's just got to be. Because there's no other way you can build that right angle triangle that stops at 5 meters and goes up 35 degrees and is anything other than 3. And that's the proof of trigonometry. Check it out. It's pretty good. Okay, so that's the first lesson on what's the basis of trigonometry and why it kind of all works together. The next video is about, well, how do we do trigonometry? And then we'll have a video on, okay, finding a leg of a right angle triangle. And then we're going to have a video on finding the angle of a trig triangle. And by the time you finish watching the 4 videos, you're going to be so smart, people will look at you on the street and say, you're so smart.